Hi guys, thank you so much for coming. And thank you, Write the Talks and Atlassian for hosting this. Okay, so introductions first. I'm Nauman Ali from APIMatic. How I like to introduce myself is I'm a software developer. I started as a software developer, and I've sweared and screamed at a lot of API docs that have not been written well. I've had to lose a lot of hair trying to figure out what to do with these APIs. And I'm also the product manager at APIMatic. And I'm going to be talking about API developer experience, right? So first things first, what I'm going to be talking about. First, the state of APIs. Where are we with APIs? How can we leverage the API lifecycle that we have, the whole different lifecycle, the steps of API development, how can we leverage that to improve the developer experience? Specifically, the use of API specifications, the different formats that come with it, the components that can go into developer experience, and the automation of developer experience itself. Finally, I'm going to give you a little insight into what APIMatic is doing with developer experience and the roadmap that we have, and if you guys can give me some feedback on that, that would be great. Okay, so the state of APIs first. So APIs have been around for some time. 2005 was when the first REST API was made, and we have seen a lot of APIs come from then. In the last 2 years, APIs have doubled in number, at least on programmable web. So now the number is around 20,000 just external APIs. Internal and partner APIs are uncountable now. So every organization, say healthcare, construction, every organization now has APIs. You can see the graph and see the growth in it. What I need to really specify here is APIs started as a thing for tech companies that were really savvy in tech, had APIs. Developers who knew REST APIs were using it. It's not a thing anymore for now. You have developers that don't know REST APIs trying to consume REST APIs. You have companies who are from different industries. They have REST APIs now. And you have to have documentation and the developer experience for it. And that's the pretext of this talk pretty much. Also, to add on to it, you have companies whose products are practically now APIs. Say Twilio, Contentful, Box, Stripe. You're going to listen a lot of that in my presentation. These are companies that started APIs as their products and have done a really good job at it and have really made a lot of money out of it. So moving on. So what's developer experience? Developer experience is practically a developer coming in, say any novice developer, a beginner developer, and how they feel about it, how the kind of satisfaction they feel when they are using the API. They shouldn't be needing any hand-holding. It should be really easy to use the API. The onboarding time should be as low as possible. The satisfaction, well, that's what developer experience completely entails. So what's the goal with developer experience? This is a very common thing in the API circle now, the 333 rule, which says that a developer coming in of any standard, of any background, should be able to understand what they're trying to do with the API or what the API does in 3 seconds. In 30 seconds, they should be able to find what the functionality is or what they're looking for. Say send an SMS using an API, 30 seconds is what should take them. And in 3 minutes, they should be up and running with the API itself. Say making the first call and getting them into their app and getting what they want to do with that. So this emoji is what you're looking for from your developer, even the worst, even like any background. This is how they should be looking if they're using your API in 3 minutes. So good DX. I'm going to be talking.
Aspirational, or people actually achieve this?
Okay, so companies that we have been talking about, Stripe, Twilio, they've come close to this. This is like the standard. This is what we want to achieve with the developer experience. Not all companies have the resources or the time to spend on achieving an experience like this, but this is like the goal with it. Good developer experience. How do you want to achieve it? These are the different components that I'm going to be talking about. I've just listed them down. I'm going to be talking about them one by one. What you want to have in your API is getting started guides, API key management, or a developer coming in, getting the API keys right from there, client libraries because you want to be talking in their languages, code samples, a console where they can try out the API, frequency of, so any questions that they might have, you need to have them answered. You need to have change logs, you need to have dashboards. So these are the things that I'm going to be talking about later in my slides. This is like a study on what the top companies are doing. And what we see here is a pattern. All of these companies are giving HTTP references, code samples, tutorials, SDKs, getting started guides, all the things that we have been talking about with the DX. are given by these top companies that have been making a lot of money using their APIs or have a lot of developers using their APIs and are happy with it. So this is what we want to do with developer experience. All right. A few examples of the kind of work these companies have been doing. Stripe is one of the most popular APIs out there. It's pretty much used by 1 million developers a day, and they're really happy developers. What they give is all of those things. Same goes for Twilio. But what these companies have done is spent a lot of time and resources creating all of these, the developer experience that they're giving. Their APIs are their products, so they can't do that. But not all of them, all of the companies have the resources or time to do this. And this is what we're going to be talking about. How can we automate this process or improve this process to improve the developer experience and not spend the kind of time these companies have? So the key to actually improving the developer experience. It's your API lifecycle. At different steps of the API lifecycle, you need to take some steps that make your developer experience or the developer experience that you're trying to give better. So API has now been treated as a product, right? APIs are no more just a supporter for things. They're being used as products. They're platforms that are making money. Companies are using this as a marketing tool or as a product itself. So what you need to do is you need to actually use the product development lifecycle right in the API. The product development lifecycle, what it says is you have the conceptualization first, the design to go with it, then the development, then you test it out, you document it, and then you maintain it. So I'm going to go through these one by one and talk about how we can improve the developer experience on each stage so that the developer experience for the user is improved. First, the conceptualization state of it. You need to create an API strategy. Once you're looking to, say, create an API, even if it's internal, external, or partner, the first thing that you do is set the goals for it. What are your goals with the API? Are you trying to make it into a business? Is this just like a supporting tool to the current platform that you have, or is it going to be used by your internal team? You need to do a user research. What kind of developers are going to be using your API? The kind that we have found out are newbie developers, say front-end developers coming in just to consume the API. You have veterans, you have evaluators who just need to know what the API does. Do they want to use it in their product or not? Or solution finders, say product managers, looking to add something to their product. And we need to get all the stakeholders on board. The stakeholders can be technical writers, developers, any of your managers. All of them need to be on board with what the strategy of the API is. So this is the first step, creating the API strategy. Then comes the design, and this is one of the most popular aspects of it. You need to have a user-focused design. What a lot of companies do wrong with APIs is they create APIs just to, say, expose their data or create a service, but not think about the users that are going to be using it. So what you need to do is focus on the users that are going to be using your API, create the functionality according to what the user goals are, name them according to what the actions might be. So a developer needs to send an SMS, you name it that, you do the functionality according to what the functionality is going to be. So base it on what the users are going to be doing with it. And always design your API to be public. Even if you have internal or partner APIs, you need to be designing your APIs so that they can become public, because companies start with internal APIs, but then they think they're going to make money out of it, or this is a very useful functionality that they want to provide and increase their platform adoption on, and they make it public. So you always need to take care of that. For that, you need to keep the usability in mind and the security of the API design in mind when you're making that public. Then next, and this is one of the biggest takeaways that we need to take away from this, I would like you guys to take away from this talk, is create an API specification. This is the first step to creating the right kind of developer experience. So how can you go about it? First, you need to choose a format. So there are a lot of popular formats out there, say OpenAPI, RAML, Blueprint. Postman's the new one coming up with their collections. So you choose any one of them. Why you choose them is there are different spec features in all of these. According to your needs, you can go through them and see which one suits you more. What your team's capabilities are. If your internal team's more comfortable with OpenAPI, you can go for it, because like I'm going to talk about later, it's not going to matter much on what format you're going to choose. The tooling available for it, OpenAPI by our studies has the most tooling available out there, but then you can even use RAML, Blueprint, or Postman, and then transform into others. Then another reason why people choose one format or the other is what kind of tooling is being used internally. If you're using one kind of an API gateway and it supports one format, you can go with that and then go do the other things by transforming it. So next thing, once you've chosen the format, you need to choose a tooling on which you're going to create that spec, because that tooling is going to be very important in you creating that spec. Why you need to choose that tooling is because you need all your stakeholders to be collaborating on the spec itself. Even if it's Swagger, RAML, any one of those, you need all your stakeholders on board while creating that OpenAPI spec. You need to be developing it, commenting on it, iterating over it so that the spec can be improved. It can contain all the features, all the descriptions, all the examples that we're going to talk about. And make it visible across all teams. So your spec needs to be the first step of the API lifecycle, and it needs to be visible to all teams across the board, be it technical writers, be it developers, be it your managers. So the next thing that we have done is created a study for the common mistakes that developers make while creating these specs. So this is from over 200,000 specs that have come into the transformer. What you see is there are some common mistakes that all the developers or all the people writing the spec make. This is for OpenAPI spec and RAML. These are available on APIMatic's blog. What I've done is I've created a set of instructions or set of common mistakes and what we can do to not make them. So the things to take care of. First, always add descriptions into your OpenAPI specs. So every endpoint, every API field, every parameter needs to have a description to go with it, and these descriptions need to be user-centric. So the users that are going to be using it, you need to be creating descriptions for them and not according to what you're programming for. You need to add examples for all the requests and responses. You need to document your errors. Define the global type. So all API specs contain type information. You can create them global, so they're reused, not go out of sync. And that way, your types would be much more usable, and you would not have to rename them or change them at different places. Use a user-friendly naming for everything here, even the API, the parameters, the endpoints, or the documentation itself. So all API specs have conventions. API Blueprint has some reserved words, so does RAML, so does OpenAPI spec, and we see a lot of developers making these mistakes. So you need to take care of these constraints and make sure you follow the conventions there are. Group your endpoints into different groups according to the different functionalities that they're providing. And the last thing, and some people miss out on that, is adding the authentication information into the spec itself, because that can be used to create a lot of stuff that we're going to create out of the spec later. Next thing is validating your API design. Now that you have a spec, you can actually validate it against a lot of popular guidelines out there. So this is a link that I've given. This is all the guidelines that there exist popularly for REST APIs. You can validate against them to see if your API is missing out on any one of these and change accordingly. The next thing that you do is you've chosen a format, any one of these, you're just going to maintain one spec. That is like, if you're maintaining if you're using different tooling and you need to create a spec for each one of them, what is going to happen is they're going to be out of sync. You're using Postman, you're using Swagger, you're going to have to create different descriptions, and then they're going to either go out of sync or you're going to spend more time developing those. What you do is maintain a single spec. If you want to use other tooling, use a tool out there. So there's one that's by APIMatic, it's a free tool. We have an API for it or a UI. What you can do with it is you can bring in any one format, say a RAML file or a Swagger file, and convert it into any other format out there. So it can be converted into a Postman, a Swagger. So you can use all the tooling out there just by maintaining a single description. So the next step. The next step is developing the API. Out of the spec, what you can do is you can create the service stubs automatically. This is the first step. You can use an automatic tool generator out there like Swagger codes in. It generates service stubs. Out of the spec, you develop against the spec because that is what you designed for. Use mocking So mocking can be used to start development on the front end even without having to develop the API itself. So this really cuts down on the development time.
What do you mean by mocking?
Okay, so a spec can be used to mock an API. What kind of response? All right, so a spec defines what the API does. You can put it into a tool, and it will act like an API server. So you can say develop your front end against the API even without not having developed the API at all. It's mocking the API server for you. So that helps develop parallelly. You can develop on the front end and on the back end without having to develop the back end first. So it really cuts down on the development time.
So let me ask you a question.
Yeah.
So you're pretty far down this path yet, but where in this process do you develop the logical structure of your resources and how that models what your service is?
Okay, so that's the spec part. That's the designing of the spec. The spec says everything about what your API is going to accept as parameters, what the responses are going to be. The whole design of that goes into the spec. The functionality is in the development phase, but that really doesn't matter because that's not the interface. The interface is the spec itself.
But the interface is not a resource oriented, right, essentially? I mean, that's the way REST APIs work. They're trying to identify a resource and say,
all right, so that's all of that goes into the spec itself, right? So all of the information regarding that goes into the spec. That's the design of it. What you do with those resources on the server doesn't need to go into the spec. That's your development on the back end. Yeah. All right, so the next thing that you can do with it, with the spec itself, is test your API. So you have designed your API, you have developed your API, now you need to test it out. This is also a very important part of the developer experience because if you don't test your APIs out, you're going to have a lot of developers coming in, finding bugs for you. What you can do is use a spec to test the API. You can use Postman, SmartBear, or API Fortress. These are 3 different tools that take in a spec, and you can create tests out of it and improve on them and do the testing of the API.
What's the third tool name?
API Fortress. So it takes an open API spec and generates test for you for the API. Then the next bit. So with having done all that, designing the API, developing it, testing it out, now you have an API, but without creating the right set of tools for it, for the users to use it, you're still going to get a really bad developer experience. And that's where the consumer-facing tools come in the developer experience cycle. The first thing that you need to do with the developer experience is get an overview. So this is your 3 seconds. In 3 seconds, the developer should be able to know what the API does and have a call to action. So what the programmable SMS API does and have your call to action on sending the first SMS. This is the first bit to it and the first component of the developer experience. The next thing that you need to do is have a sign up in API key management, which should be a self-service in the best case scenario. You have somebody come up, sign up with their credentials. You can use single sign-on, say GitHub or any one of those. Have a developer sign on, give them some sort of credentials, production and sandbox so that they can get started with using the API. The next thing that you need to do, and this is a very important bit, is the SDKs and the client libraries. So APIs, like we talked about, are not anymore used by developers who know REST APIs, who know how REST APIs work. You have them using in all sorts of languages. So there's a quote here that I really like. If you talk to a man in a language he understands, that goes to his head. If you talk to him in his language, that goes to his heart. So this is what Nelson Mandela said, and we have 46 million developers using APIs or trying to use APIs in different languages, and we need to be catering for all of them. So for that, what you need to do is provide client libraries in all those native languages with all the abstractions needed for the API. You have all the popular APIs out there giving these client libraries. So Stripe, Twilio, Box, Facebook, all of these give these client libraries in all these languages. What it helps is all novice developers coming in who don't know REST APIs can use the REST API. You don't have developers doing the redundant work of authentication, of what parameters need to go where. This can be done by the client library itself. You have different platforms being used for your API, and the developers can focus on the creative bit and not on the redundant bit, which is done by the client library itself. And yes, you can automate this bit too. So with the spec, you can use one of the client generators. APIMatic is one of them. Swagger CodeGen is another. which generates client libraries out of a spec file, any one of those, say a RAML file, a Swagger. You can put that in, create these client libraries, and provide the kind of developer experience that Stripe or Twilio kind of APIs are providing. The next thing that we need to do is, so now you have the SDK and the client libraries. You can't just give away those client libraries and expect the developer to figure it out. You need to have tutorials and code samples for the SDKs too. And for that, what you can do is, again, you can also automate that bit. So with the client generator that you're using, say APIMatic, you can actually have code samples, tutorials automatically generated for all the languages. All you need to do is create the right spec, put that into the generator, and you will have the code samples and tutorials for it. What these tutorials and code samples have to contain are installation instructions on how to install the SDK, the getting started bit, on how to authenticate the API, and code samples for every endpoint, and how to use those endpoints in the SDK. The next bit is the API console. So a developer comes in, you can't really expect them to commit to writing lines of code to use the API or getting some sort of credentials or signing up before actually trying out what the API does. So for that, what you need to provide is the API console. So this API console can be used to try out the API, see what the behavior of the API is, see what it does with different parameters, without writing a single line of code, no commitment. They try out the API and see what it does. Again, you can either use Swagger, APIMatic, README. There are other tools out there too that create the documentation and the console for it. So out of the spec, you can create this console too. The next bit is the status page. So with APIs being used so commonly, say Facebook's authentication API is used in thousands of apps to authenticate and identify users. If Facebook's API goes down, there will be so many apps that won't be working anymore. So you need to have your developers, have your users really aware of what the status of the API is. For that, you need to have a status page. Again, you can automate this bit too. So there's a statuspage.io, a service bit Atlassian, which allows you to automatically show what the API's status is. You need to have that on your developer if you're looking to, or on your developer portal if you're looking to provide the right developer experience. The next bit is API use cases and workflows. So you created the API, you provided some endpoints, you provide some sort of functionality, but the developers normally are coming in to perform one specific action. They can be a set of endpoints used in a particular order. What you need to do is identify those workflows, identify those recipes that the developers use so commonly, and provide the helper code and documentation or SDKs or client libraries for it too. This bit, because it's not standardized in the spec itself, cannot be automated. But if you're looking to provide the right developer experience in the least onboarding time, you can create these, document these, and put them on your developer portal. All of the popular ones like Stripe, Twilio again, provide these use cases and developer experience. So next bit. And so these are the developer components that are pretty much necessary if you're providing the developer experience. What you need to add on to it is FAQs. So any questions that the developers very commonly ask need to be on an FAQ page for the API. There need to be a support forum. So questions that developers need to ask, they need to be, say, use Zendesk integration or Intercom or any one of those. Put that onto your developer portal and have your support team respond to any questions that the developers might have. Another thing that's coming up now is analytics or dashboard for every API user out there. So the API user can see what kind of calls they've made, what responses they've gotten, how many calls they've made, and what's the status of the API, all using their dashboard. So this is also provided by a lot of popular APIs. The pricing of the API. So this is only for APIs where it's applicable, but if a developer is coming in, or a user, say a CTO is coming in to see what the API does and do they want to use it, they need to be able to see the pricing for it. The next bit is the discoverability of the API. So for that, you need to see what your users are. If it's an internal API, you can have an internal directory where all your APIs are listed. And any developer who's looking to use it, don't make them write code or APIs again. Just have them go to the directory and find out the API and use it. External directories like Programmable Web, Rapid API are popular ones if you're looking to expose your API and have a portal for it and market it.
What do you mean by a directory? Just like a web page that lists all the endpoints, or I don't really know what.
Okay, so an API directory is a list of APIs. So a place where you can search APIs. Say you're looking for a messaging API, you can go to programmable web, search messaging, and you will have all the messaging APIs listed for you. So it's a search engine for APIs practically.
Just like an index of them.
Yeah, yeah.
Okay, fine.
And you need to have, if you've done all the developer experience bit, you have done all the things right, but if your API is not discoverable, it's practically not usable for developers. You need to market your API portal. Then once you're done doing all these developer experience things, you have provided the right developer experience, this is not where it stops. You also need to be able to maintain the API right. For that, versioning is the first aspect to it. Because APIs are used so in places where you can't really break stuff, you need to version your API right. There's no specific standard of versioning. You just need to figure out what works for you best. But version your API, update the spec, create change logs for it, and well, communicate to the user the changes that you have done. So always keep your communication open to the user. Have your change logs updated on your portal so the user knows what's changing in the API. All right, anyway, before I go on to the APIMatic bit, you can ask me any questions that you might have regarding this.
So you talked a lot about like, companies that are doing APIs really well, and then a lot about automation. Do you know which of those companies are actually using any tools to better SDKs and better APIs?
Yeah. So Stripe and Twilio, the conversations that I've had with them, they're not using external tools because they started very early with this process. But they've created generators of their own because this is with SDKs and client libraries, it's not just creating them. You have to hire developers to maintain all these languages. And then whenever the API is updated, you have to make those changes in 10 different libraries. And that's where a generator, even if it's internal, if you have those kind of resources, or an external one that helps you really cut down on time and cost to market that API out, market the SDKs out, and having the idiomatic SDKs across different languages. So, yeah.
Do these different API spec formats work for APIs that aren't REST APIs? If it's like a .NET or an iOS library, do those same formats work, or are those kind of strictly for REST APIs?
These formats are strictly for REST APIs. There are some for SOAP APIs too, like WSDL, WARDL, but these are for REST APIs, yes.
So I believe you're a product manager for this, right? Not a technical writer.
Mm-hmm. No, I'm the product manager, yes.
Yes, you're a tech. So my question is, I imagine that many of us here are tech writers and saying, that all sounds good, but how do I get involved when a product manager is going to be developing an API? So for how does your company do it? Do you go and when you're developing something new, scoop up a tech writer, or how do we apply some of this good knowledge we've gotten now?
Okay, all right. So with technical writers, like I said, whenever you are creating APIs, the focus of the API should be how it's going to be used by the user itself, right? So that comes with the kind of documentation or the kind of experience that you want to provide for the users. Some of this can be automated, like I said, like the SDKs or the client libraries, but some of this you need to write on your own, which the technical writers probably would end up writing. And
so
that
is
is
expected then the product manager, like you probably have a team of several people you're working with, some software developers, and you would include a tech writer on your team then?
Yeah. So how in the scenario that I'm trying to explain, you start with having all the stakeholders on board and having all these discussions when you're designing the API itself, because this is eventually going to be provided to your developers, say internal or external, and that is when you need to have technical writers on board too as to what kind of documentation, what kind of experience you're going to be providing for the API itself. And starting from there, you get to the end where you're providing all this that we're looking to provide. So this is pretty much, any other questions? Yeah.
It occurs to me, and I'm wondering what you think, in your life cycle thing from way back then, documentation pretty much was sort of at the tail end of the cycle. And it occurs to me, I wonder if the documentation might serve better between conceptualization and design. I'm thinking it could serve as basically defining what the API should do, maybe be the specification as you go along. Does that sound reasonable?
Yeah, so when I say in that cycle, when the documentation said that's like the developer experience for the consumer side, like I said, the consumer facing developer experience. What you need to start with is the spec, and that's where most of the documentation goes. The descriptions, the parameters, the examples, all of that, that's where a lot of the documentation resides. You can create a lot of stuff out of it. This is the consumer facing bit that comes onto the tail end of it. So you start with the spec, document it right there, and then you create the tools out of it or add on to it for the developer experience. Yeah.
I think it's helpful for this group to know that the spec for APIs, whether it's in the flavor of RAML or Swagger, the spec is a markdown language itself. So if we as technical writers are used to some kind of markdown language, markup language, markdown language, API developers have also decided that a markup language allows them to create a specification for the API that they want to propose and eventually develop. So that's how an API specification can kind of auto-generate work products because it is a markup language itself. RAML is a markup language. Swagger is a markup language. What are some other?
There's API Blueprint, there's Postman. So all of them contains some sort of markdown in there. Yeah, and that is where the documentation mostly resides for the API.
I was just going to mention too that when you're creating that specification, a writer is really helpful to have on the team, because when you're creating the specification, a writer will have a perspective of the person who's going to be using that API and can suggest to the development team what the naming conventions should be. And when you had a sub-point there, you said follow the conventions. And a writer will have a sensitivity to that you may have an internal language that the developers are speaking to build the product, which may not map to what people on the outside are going to use. And so, but if you get those names right early on, it can really help with adoption, because you don't have to explain names that are different from you or wonky. So getting the writer involved early in that aspect is really important.
And because you're right. So with the spec, what you're looking for eventually is it's going to be exposed to the user. When a developer ends up writing a spec or just adding stuff to it, they just name it according to how they are developing, not user-centric description. And you want it to be user-centric because that's going to be eventually the tool that's going to be creating the documentation or creating the stuff that's going to be user-specific. And you really want the technical documentation to be according to the user. And that's where a writer can come in and really help with that.
So when you outlined this earlier, I think you said that you would write the spec first, and then you would use the spec to generate stubs that the developers could then use to develop the software. Is that the model that you're talking about?
Yeah. So with the spec first design, this is how you can go. So the spec is kind of a mock-up for the product. Say the description on how the product would be. You create the documentation out of it, but you can also create the server-side code, like the stubs out of it, and then add the functionality to it. What that helps with is it creates APIMatic code, and you can just, whatever the changes are, the spec, the server-side code reflects that.
So how do you deal with that? I mean, presumably you use more than stubs, you actually develop code. And what happens if you change the spec after that and develop a whole new set of stubs? What's the process for aligning the software after the development?
Okay, so you have created the stubs, you have added stuff to it, and now you have changed the spec. Depends on if you're adding a new endpoint, it's just going to create a new endpoint. Normally how people do is just scripts where stubs are just like skeleton. So the skeleton's changed, say the parameters or the naming of it. What's inside it can't be changed because that's not coming in from the stub. So they normally write scripts to actually change over the code.
But I mean, suppose they change something that they've already coded, not adding just another endpoint, but maybe changing the way a certain endpoint works.
That's not in the spec, neither in the stubs. The stubs just contain the name of the endpoint, the parameters, whatever the spec contains. But the logic,
Change one of those things.
it's just a script that changes that part, that bit of it. So normally that's how companies are using it to create service stubs.
Most of this my question's been answered by the last three people, but I wanted to ask, just so I'm absolutely certain, the spec is not something like, in the old days, you'd write a spec in a document, and then you would implement that spec, and then it was only the code that would live on after. But now it sounds like the way that specs work for REST-based APIs is that they live on and continue to be an active part of the application and change along with the application. In fact, change before the backend code, and
That's the practice that's being suggested now. You create the spec first, you develop according to it, you document according to it, and if anything changes in the, if you want to change anything in the API, you change the spec first and then go on from it. So it's a spec first design.
So it sounds like if you're going through the process of versioning, then you first version the spec and then publish new stubs or translate,
Yeah.
existing stuff.
So if you're creating a new version, you decide what you want to do with the version, the design phase of it. Then you would add that to the spec, then do the server-side code, then generate the stuff that we are generating out of it. So the spec comes first in all of this.
The spec is the linchpin of all of this.
Yeah, it's how it's put is it's a single source of truth, and everything else comes out of that. So that's your single source of truth, and everything else comes out of that. Yeah.
So are there ways to, or there tooling to prevent unintentional or accidental changes? Because as you said, if you change the spec, it flows right through. What happens if you unintentionally make sort of a backwards compatible change? Are there tools to check for that?
Tools to check for that? No. So this is like versioning. There's no specific way of versioning, but whenever you're changing anything in the API, you normally create a new version for it, and that's up to you. If you're changing something, being a breaking change, you change a major version of the API. If it's a minor change, you change it, version it accordingly. But there's not a tooling that I know of that does that for now. We're working on a roadmap thing where we can create automatic change logs out of the spec. So two specs can be compared and told if there's a breaking change or if there's not a breaking change. But there's nothing in production that I know of that does that for now. Anything else?
Is a question about programming languages like Java, Python, C, is that out of the scope?
No, go on, ask.
Can I ask a question?
Yeah.
Java doc, PyDoc,
Mhm.
and Doxygen.
Mhm.
Do you have comments that cover the use of those tools?
Do you have comments that cover?
Do you have any comments about the use of those tools with respect to your presentation?
All right, so Java docs and all of those were normally created for, say, libraries that were written in Java or all that. What that primarily said was you coded in Java, you wrote some sort of, did some sort of commenting and all that, and that created the documentation for it. But that's called documentation for the server side. What we're looking at is this documentation for the client side of it, or the client. So it's a little different in that perspective.
You can have a C++ core application that is publishing an API that has REST endpoints.
You can have it in any language, have a REST interface for it, and then be consuming it in, say, iOS, Java, all of that, and providing client libraries for all those languages. Because you write it in C++, that's up to you, or Node or anything. But your developer wants to consume it in iOS, and he wants documentation in iOS on how to consume that API. That has nothing to do with which language you did it in. Any other questions? All right, I guess this is pretty much it.
So how do you generate SDK documentation?
I'll show you a demo for it actually. So out of a spec, say a Swagger file or a RAML, what you can create, say using APIMatic, and there are other tools out there, is a portal like this. So this is all created out of the spec. What there is this landing page. This is all customizable visually. A developer comes in, sees what the API does. So this is the messaging API. All of this is marked down. You can put in information there. What the API does, click Get Started. and it takes you to the documentation for it. So what the documentation, once it loads, would contain is documentation in all the languages that the code is generated in. Plus there's an HTTP level documentation. So yeah. So all the languages that it's so a developer comes in, say wants to consume this API in .NET. He chooses his language, gets the different flavors for it. There's an SDK which contains all the logic on how to call this API, how to authenticate this API. All of that's done in the SDK. The developer doesn't need to care about it. Then for the SDK that you get, you have this documentation already automatically created on how to build this SDK, how to use this SDK, how to test out this SDK.
What do you mean automatically created? How did it get created?
From the spec. So the spec contains all the information on how to authenticate, on what parameters are there. What it does is practically a translation to all the languages and creates the helper code for it. So you design and create the spec, and this is created out of the spec itself.
By APIMatic or by the various specs tools like Swagger or
Okay.
Contribution tool?
APIMatic does it too. Then there's Swagger CodeGen that does the code generation. So there are 2 or 3 different tools that does this. APIMatic is one of them. This is APIMatic's output of it.
Okay. So in this example, it's APIMatic that has created this documentation.
Yeah.
automatically.
So into the APIMatic service, you bring that spec, and out of that you can create this documentation. Like the kind of developer experience that we were talking about, this is bits of it. Then you can use all the other integrations or the automations that we were talking about.
So you're actually generating stubs for your SDK out of your API spec?
Okay, so SDK stubs, when we say, are server-side steps. That's server-side implementation. When SDKs are client-side libraries, so if you want to consume this library in .NET, instead of actually having to make REST calls, attach headers, attach form parameters, all the stuff that comes with a REST call, you can use this library and just call a function in .NET and do what you're trying to do here.
Right. So I'm trying to get at how you get the documentation of the SDK.
Because the SDK was automatically generated.
So that's what I'm trying to get.
Yeah.
How do you generated the SDK automatically from what?
From the spec.
From the spec.
Yeah. So you bring in a Swagger file, we'll generate the client libraries and the documentation to go with it. So this first, this SDK right here that you can download is automatically generated. This contains all the code. Then you have the documentation for the SDK. So on how to initialize the client, how to authenticate it, all of this is automatically generated.
But I think our question is like a step back. Are you sitting in a console and you've got a command line and you type some command that then parses the spec file to create this magically?
All right, there's 2 versions to it. You can either use the UI, APIMatic has a UI where you first upload a spec file and you can create that out of it. I don't want to go through the process completely. This is the output of it. Or you can use our API to create this using an API, but well, there are 2 ways to go about this. But out of that spec file, any one of those formats, you can create this documentation in SDK's format.
So, but you maintain separate sources for the different SDK documentation? So, for example, if I have a Java SDK and a Python SDK and a .NET SDK, do I have separate sources for the documentation for each of those?
Separate sources. So the spec is your only source. The spec is where all the information comes from.
But what do I print from?
What do I?
If I want to generate a PDF of my documentation,
Okay.
what is the source for that PDF?
This is Markdown. You can use this
So so you have a single source for everything and it's automatically generated. It seems too good to be true.
Okay. Let me actually show you how it's done. So let me open up APIMatic. All right. So how you go about it is, the first step is the spec, which is in this case this YAML file. So this is a Swagger YAML file. This is the source we're going to use to create the documentation and the SDKs, right? You can import that into APIMatic. Say I put that in here, click import. It validates the description for you. So the description's validated, and then out of that spec that we just imported, you can create an API portal. So you can either create SDKs right here or the API portal bit. So out of this spec, now we've just created the API portal that I was showing you. So that portal, what it contains is SDKs, the documentation, because at the end of the day, it's just mapping the spec information into languages of there are, right? In
But an SDK has to sort of have the flavor of that particular environment. Like a Python SDK isn't going to look just like a model of the API. It's going to look like a Python library that does certain things.
Yeah, that's what the generator does. The generator that APIMatic has, or the generator that Swagger CodeGen has, you give it a spec, the generator translates that into the languages of there are, right? So into a Python library from the spec. The spec has the information, the generator knows how to translate that into a Python library.
So suppose when it's done that, and I look at it and I say, hey, that part of it's not really very Pythonic. Suppose I want to modify a piece of it here or there. What source do I go to do that?
Okay, so if you're looking to change the Python code, unless you're looking for some sort of customizations, those Python code, say in Swagger CodeGen, it's open source, so you can just go and change the generator. With APIMatic, you can tell us to do some customizations, but if you're saying if it's not Pythonic, then that's something that the generator is not good enough. The generator is supposed to be good enough to say that if I'm generating Python code, it's as good as Python code can be written. So this
you
is
probably optimize the Python code. You look at the actual code and optimize it, rewrite it, and test it.
Well, where is this actual code?
So you just take the Python code and you put it in your SDK where you're working with, right?
So the output is Python code. If I'm getting a Python SDK, there is a Python source that I can then mess with.
Yeah, there is that, but with the generator, what you're trying to look at is you don't need to change that. It's automatically generated. So going into that is then taking away what automation brings you, cutting down on the time and cost required to actually market out this.
If you've got a Python or an architect, they'll probably say, okay, we'll use it, that's fine. Because you've got they have more way of doing it, and they can probably optimize it a lot better. But it's just like something to start off with, especially if you're new. It's like, okay, awesome, let me get the Python out of it.
And with the APIMatic generator and the Swagger generator, you have a lot of customizations that you can put into the spec. Extensions that say, okay, I want to add this to the code or add that to the code, and then you can make all sorts of customizations on the code too.
Is all this true for, say, Swagger also, and for all the others you mentioned, or just API?
APIMatic is the code generator. Then those are the spec formats. So the spec formats are just spec specification formats. The code generator generates the code. There are just two code generators out there, APIMatic and Swagger CodeGen. Swagger CodeGen is an open source project. So yeah, you have two options.
It generates SDK code?
Yeah, it generates SDK codes too. It doesn't generate the documentation to go with it like this one, but it generates the SDKs, yes.
It seems to me there must be a specific structure to the specifications. Are there rules?
These are all formats that I talked about, OpenAPI, RAML, Blueprint, all of these are standards. You bring them in those standards, and then the code and documentation is generated.
They're all YAML, aren't they?
Not necessarily, but some of them are.
Swagger.
Swagger is YAML, yeah. Swagger is JSON too, it has both versions to it. All right, so I was showing the getting started guide. Then you have custom documentation that you can add. So this is just markdown documentation that you can add, say talking about the API authentication, anything that you want to add on to the automated documentation. This is where a lot of the custom things would go. Then you have endpoint documentation. So if developer comes in, wants to send an SMS, he gets all the documentation for it. The name, the description, the signature in the SDK, the parameters documentation, the response types, the scopes, the errors, all of this is documented coming in from the spec in .NET. Then on the right, what you get are like the code samples that I talk about. So the SDK you have, now you want to use the SDK, you get the code samples and how to use the SDK. So the SDK can be downloaded from here. The code sample is on the right. You click show complete file, so it's a complete file. You copy this, you take the SDK, and you can get started with the API without writing a single line of code. You can actually play around with these code samples too. So you put in values, they are built on the fly. They're built on the fly in every language. You get the code samples, you click try it out, see what the API does. So this should call the API, show you the response from it. So a developer comes in, chooses what language he wants to use the API in, gets the SDK, sees what the API does, copies the code, and he's, if not 3 minutes, in a short amount of time onboarded onto how to use the API in his own language. He doesn't need to know REST APIs. He doesn't need to know like how REST APIs work or write any of the code. That's all done in the developer experience portal. And you can use many other tools to automate this process. But the whole concept is create the spec, put the documentation in there, use toolings. There's a lot of tooling out there that can help you automate a lot of bits of it. Automate those bits, and then the bits that you can't automate, put that in, and you have the perfect developer experience for your APIs, or the ones that you're looking for with the least amount of time. So this is pretty much. Any questions? Yeah. Go on.
Yeah, so we go back to that endpoint stage.
Yeah.
So my understanding of, for example, Spider of the API set primarily contains just this information for the endpoints. Is that correct?
It contains the parameters information, the response type information. So what the parameters are, the responses are, the errors are. What?
So in this portal, there are lots of other pages with other documentation. Those aren't part of the Spider of the API.
Okay, so once you know this, you need to send an SMS, you know how to authenticate it, what parameters you're sending, what response type, all of that has been into the spec. What this documentation adds on to is the SDK that you just downloaded needs to be installed, and that's automatically generated, so the documentation for it is created too, right? On how do you install the SDK, how do you initialize the SDK, because that's a library and you need to document that too. But that's automatically generated, so the documentation is automatically generated too. That doesn't need to come in from the spec.
Right.
Yeah. So, but that's not needed because the generator knows how it generated the SDK, so it knows how to document it too.
Right. So in this portal, there are lots of different pages. But is it only this one that's coming from the OpenAPI spec file?
This is completely generated from the OpenAPI spec. You don't need to add any other information except this guides part, which is the place where you can add extra information, anything that you want to add on to. Markdown documents, say talking about the API authentication, anything that's custom to you. But everything else is generated from an OpenAPI spec or added onto it.
And like the screenshots, also that's something that...
Yeah, you don't need to put any information for that. The generator that's doing it knows how it generated the SDK for the API and the instructions that it needs to generate from it. The only source is the Swagger spec.
The screenshots.
Yeah, the screenshots just coming from the generator. You don't need to put any extra information for that. So I just imported that spec for you guys, right? This is what created from that. Only this added part is this custom docs part that we added as Markdown.
Well, that's where the getting started, the use case recipes, all of the tutorials, that kind of work would potentially go into the custom docs.
Okay, yeah, so in the guides or however you want to name these sections, you create FAQs. Maybe you add a status page, you add terms of services, anything that that is missing in the automated generation of it, right? The eventual goal with the developer experience tool is to automate this whole process, but you don't have it automated, so you add the extra stuff right here. Or you can actually embed this portal into an existing one which contains all of that.
Yeah, if you look at our, I don't remember the URL by heart, but if you look at our Bitbucket spec for our API, it's a massive JSON object. Like it has a boatload of information. So, and you can get it per URL.
Okay, yeah, that's pretty much it from my side.
Okay.
Thank you.